Hello everybody, welcome back. Today, this is a video as part of a Trigonometry Algebra 2 video series designed to help you prep for the upcoming Trigonometry or Algebra 2 Reasons exam. And here is the problem. The problem states this. If the roots of quadratic equation, which is ax squared plus bx plus c equals 0 are real, irrational, and unequal, then the value of discriminant is okay. So we have four choices and 1 2 3 4. Okay, we can solve this problem only when we know the idea behind discriminant. If you don't know the idea that is behind discriminant, it is going to be hard to answer this problem. So let's explore the areas for discriminant. So obviously, if ax squared plus bx plus c is equal 0, this is quadratic equation, and if this equation is not easily factorable, then we can use this formula to find the individual roots, which you may have seen in your class, in your trigonometry or algebra 2 class. So the formula is negative b plus minus radical b squared minus 4ac over that is not b, over 2a. Okay, so how do I get this b, a, and c? So if you compare your equation, any equation for this standard equation, let me create some random equation. So 5x squared plus 6x minus 4 equals 0. This is random. I don't know the roots for this, so just for the example purpose, so let's explore the area. So if you compare this equation with this, a would be 5 because that is the coefficient of x squared. Similarly, b would be 6, coefficient of x, and the constant, which is c, including the sign itself, would be negative 4. And that is what you need to plug it into this formula to find the roots. But I'm not interested in finding the roots of this problem. What I need is to find what prompts me to tell me this is what it is. This is what is real for this equation, like under what condition, either this 1 2 3 or 4. So the discriminant part, which is, let's say, d, is only this 4ac. so this is the discriminant part, and this is very important, which helps us understand the nature of our equation, like how the equation is behaving. I mean, the general behavior, for example, negative or positive roots, equal, unequal, rational, irrational, imaginary, all sort of these things. So there are 4 different distinct rules that you need to remember for you to answer a problem like this. Not only this problem particularly, but problem in general referring to quadratic equation. So let's go back. So the rules are, let's say, let me create a table. Okay, so this is D table, and this is the rules. Okay, so according to D table, it is important to know the differences between these tables. For example, let's say you solved b squared minus 4ac. You plugged in all the values b, a, and c, and you solved this part b squared minus 4ac. I'm not using roots, only this b squared equal the discriminant equal b squared minus 4ac part, and that turned out to be equal to 0. Okay, so this part turned out to be equal to 0. So what do we know? We know now the equation, the quadratic equation, only have one real solution. Okay, so what does it look like in terms of graph? In terms of graph, it looks like this, something like this. Like it will only touch here, or here. Excuse my drawing. So the bottom line is it will only touch either facing upward or facing downward. The only point of intersection to x-axis with this equation, the curve, would only be 1. So that is one real solution. And how do we know that? When you solve b squared minus 4ac and your result is 0, instantly you know you have one real solution. So second condition would be you solve 4ac, b squared minus 4ac, and that turned out to be a perfect square number. Okay, perfect square number. So what do I mean by perfect square number? Obviously, right? So let's explore in terms of examples. So let's say I solve this, okay, b squared minus 4ac, and that turned out to be equal to 9 or 16 or 25 or 36. Are you getting the picture? All the perfect square number, positive, obviously, perfect square number. So if you happen to get a perfect square number once you solve that b squared minus 4ac, then what you have is you have two real rational solution. Two real rational solution. Okay, and what does it look like in terms of graph? Let's do that. You know what, I'm going to draw my graph here. In terms of graph, it'll look like this, something like this, something like this. So one you have here, one you have here, and you know, like for example, -4, 0, you know, a 5, 4, a 5, 0. These are all imaginary coordinates I just created, but sort of give you an idea of what coordinate looks like under this condition right here. So when you have b squared minus 4ac, which is perfect square number, you get a two real solution, two real rational solution. Okay, so let's explore another condition where d happens to be b squared minus 4ac, but then is not a perfect square, so not a perfect square number. Okay, but this also can be written as b squared minus 4ac, which is obviously greater than 0. This is also b squared minus 4ac greater than 0, but in my case right here, b squared minus 4ac is not a perfect square number. So as an example, 4ac, this is 4ac. So let's say it's equal to 3, 7, 11, 12. You know, it's all positive number, but it's obviously not a perfect square number. So what do we know now? We know this rule tells us this also has two real solution, and they are irrational. Two real, let's not write that comma. So, and there are two real irrational solution. Irrational solution meaning something like radicals, you know, radical 5 coordinates. I'm just gonna draw right coordinates for you. You will end up having this. This is sort of example, not exactly the same number you're going to get, but something like this. You know, when you solve that radical 5 in a calculator, the number after decimal is not going to end. And that is what irrational number is. Repeating number or a number that is going to the infinity may have some pattern or may not have some pattern. That is not to our significance here. But the whole idea is, if a number is on the radical, is not rational, is irrational, and the rule states if b squared minus 4ac is not equal to a perfect square number, but it is greater than 0, which is part of that example, could be any number, but not a perfect square number, the rule tells us you have a two real irrational solution. Okay, and what does it look like in terms of graph? It looks like the same thing, like this, or up or down, it doesn't matter, but instead of having coordinates, you see how nice it was negative 4 0 or 5 0 kind of thing. Now you would have negative 5 0 radical, meaning those roots are irrational. Okay, and there is one more rule. This is the last one. So d b squared minus 4ac is less than 0. So what does it mean by having less than 0 number? Minus 4ac, you solved it, is just an example, and then you happen to get negative 4 or negative 22 or negative 25. It doesn't matter. When you have a negative number, there is no such thing negative perfect square number. Let's not confuse yourself with, oh, guess what, I found negative 25, it must be part of this thing because it says perfect square number, right? No, because it's negative, so forget about it. There is no perfect square number, or that is not a perfect square. Everything that has negative will follow this rule right here. And negative 25 less than 0, it says the rule says no real solution. In other words, imaginary numbers that cannot be seen into the graph directly, imaginary roots. Okay, I understand what imaginary roots is just by seeing what I wrote, right? But what does it look like when you want to see in terms of graph? So let's do that. Let me draw two types of graph. One is this and one is this. So there are two types of curve. One is going up, one is going down. You notice, one more time, do not confuse yourself thinking this might be roots here. This is not a root. It just happens to be an intersection between a curve and a y-axis. Root is the intersection between a curve and the x-axis, which is like this. Okay, so these are not roots, but you notice there is a significant distance between my roots from the x-axis, meaning there is no point of intersections. These roots, I mean this equation, this curve, are never in their lifetime will intersect x-axis, right? So that is why when you have this kind of conclusion, I conclude myself my roots are something like this, either this, and you don't need to know or need to draw what the graph looks like. It's just for sort of your understanding. What does it look like in terms of graph? If I want to see in terms of graph, some of you may be visual learner, you want to see what does it look like, and this is what it looks like right here. Okay, and we have 4 rules we just developed. First rule equals 0, second rule perfect square number, third is greater than 0 but not a perfect square number, and a fourth is less than 0. So we have developed all the rules. These are the 4 essential rules you need to remember. Practice this with a couple of problems. Let me shorten this rule. So let's say the discriminant is represented as d. D equals 0. D perfect square, right? D not a perfect square, and d less than 0. Okay, so d equals 0 to real solution, and d equal perfect square number to real rational solution. I think I made a mistake. That's not 2, that's 1. 1 real solution. Okay, and then not a perfect square number, still 2 real irrational solution. Okay, and imaginary roots. Okay, so I mean, if you want to see the clear explanation of that roots is, you can follow this table, and then once you follow this table a couple of times, you can sort of remember in terms of this format. Helps you understand better because it's shorter, less content to memorize. Okay, so we have all the tools necessary for us to solve this problem. Let's go back. It says if the roots of a quadratic equation, which is right here, ax squared plus bx plus c equals 0 are real, irrational, and unequal. Okay, so what do we know now? Is it equal to 0? Equal to 0, it says one real root, so it's not equal to 0. Is it less than 0? Okay, less than 0 says no real solution, right? So that is also not true, right? Okay, greater than 0 and a perfect square number, which follows this right here. Greater than 0, right? And oh, not that, sorry, not this, the second one. Okay, so greater than 0, right? And then perfect square number, correct? But then that says two real rational solutions. So, but the question asking us what would be irrational. So guess what? 3 is not also your answer. Your answer would be the fourth one. And I know some of you observed the content, and it said an unequal, right? Okay, I mean, I left that part out, but it doesn't really matter. Once you have irrational, and it's actually unequal roots, and that is only happening when you have this condition where b squared minus 4ac is greater than 0, but is not a perfect square number. So your answer is 4. Okay, so this question, you can actually solve it within like 30-40 seconds tops, but you need to remember this table. If you don't know the table or that understanding of discriminant it'll be very hard to solve this problem. And mind you, once you have this table memorized in your mind, you can actually go ahead and solve any kind of problem pertaining to a quadratic equation. Thank you for watching. Please don't forget to subscribe my videos and channels so I can continue and develop more videos for trigonometry and algebra 2 to help you prep for a coming Regents exam. Thank you.